Okay, I want to re-go over this example 3 from lesson 6.3, but first I want to talk about a little geometry that I want to make sure everybody understands, because we haven't really talked carefully about this, and I want to make sure everybody understands what happens when parallel lines are cut by transversal and all that. So when two lines intersect, vertical angles are congruent. So those are vertical angles, and they're congruent, which means they have equal measure. And those blue ones are also vertical angles. They have equal measure. Now, when parallel lines are cut by a transversal, there's two parallel lines. The top and the bottom lines are parallel. They're both horizontal. When parallel lines are cut by a transversal, the transversal is the slanted line, then we say that corresponding angles are congruent. So this red angle right here is below the horizontal line and to the left of the transversal. This red angle down here is also below the parallel line and to the left of the transversal. So those are called corresponding angles, and they are congruent. It just means that the transversal cuts the parallel lines in exactly the same angle in all positions. So this angle, this red one at the top, is also going to be congruent to this red angle, because both of them are above and to the right of the transversal. They're above the parallel lines and to the right of the transversal. This blue arc, this blue angle, is going to be congruent to that blue angle, because they're both above the parallel line and to the left of the transversal. This blue angle is going to be the same as this blue angle, because they are both below the parallel line and to the right of the transversal. Corresponding angles are congruent. Now, one more thing. When parallel lines are cut by a transversal, alternate interior angles, so watch carefully at the blinking angles. These are alternate interior angles. They're inside the parallel lines, and on the opposite sides of the transversal, they are congruent. There they are again. Two other alternate interior angles and alternate exterior angles. So watch the blinking angles outside the parallel lines on opposite sides of the transversal. They are the same, and those guys also. Okay, a Coast Guard ship on a routine training run leaves its base at 16 knots on a course of north 82 degrees east. So north 82 degrees east. 3 hours later, a distress call comes in from a cargo ship. So 16 nautical miles per hour times 3 hours is 48 nautical miles. So that ship will have gone 48 nautical miles. And at that time, after those 3 hours, a distress call comes in from a cargo ship located 180 nautical miles from the base at a bearing of north 48 degrees. And so the question is, how far is the Coast Guard ship from the cargo ship? And we're supposed to round to the nearest tenth of a nautical mile. So we have this triangle, and obviously we're going to use law of cosines to figure out that red line, how far the Coast Guard ship is from the cargo ship. And so we need to know the angle inside that triangle that has its vertex at the origin. So that's going to be that 82 degrees minus the 48 degrees, and that's going to give us that angle, which is 34 degrees. So now that we have that angle, we can find that red side A, because we have two other sides and an angle, so the angle between them, so we can use the law of cosines. So that's what we did. A squared equals 180 squared plus 48 squared, and 48 is that side of the triangle, not that angle 48. Minus 2 times 180 times 48 times the cosine of 34. So that's the angle opposite to A. And if we do all that out, we get 142.8 nautical miles, and we did that in class. So that's the answer to part A. Now we want to know what bearing should the Coast Guard ship follow to reach the cargo ship. So that's what we have to figure out, that angle right there from north. All right, so to get that, the first thing we're going to do is work with this triangle some more. We're going to get this angle right here, this angle C in that big triangle. And so to do that, we're going to use law of sines again. We have 180, which is across from that angle, and now we have the two other sides, 142.8 and 48, so we'll use that law of cosines. So 180 squared is 48 squared plus 142.8 squared minus 2 times 180 times 48 times the cosine of C, because C is the opposite side to 180. And if we do that, we get that C is 135.1 degrees. So there's that angle. So to find the angle we're looking for, that red angle, I'm just going to blow this up bigger. Okay, so this is what we've got. We're trying to find that angle right there. And so we can remember that if we look back at the beginning of the problem, we have that 82 degrees as the bearing for the Coast Guard ship. And so what's left right there at the bottom, that tiny little angle, is going to be 8 degrees because that whole quadrant is 90 degrees. So that's 8 degrees right there. And you can see that the two x-axes in this picture are parallel lines, and they're cut by that purple transversal, and so the alternate interior angles are going to be equal. So this angle right here is also 8 degrees. And we just found out that angle C is 135. So we need to find alpha, that angle there. We've got that 8-degree angle, and we know that this angle right here between the x-axis and the y-axis is 90 degrees. So alpha is going to be 135 minus that 90 degrees minus that 8 degrees, and then we would have alpha. So that's what we end up with. Alpha is 37.1 degrees, and therefore the answer to the problem is north 37.1 degrees east for the bearing that the Coast Guard ship should follow to get to the cargo ship.